let's say I gave you the choice of solving this quadratic equation or this quadratic equation. If you've got some experience in both of these setups, you would probably choose this one, because this one, you would have to subtract 3 from both sides, then factor it, then you would subtract 3 from both sides because you want 0 over here. And you factor it, set each of the factors equal to 0, and then find the solutions. And that's not that big a deal. But this one over here, all you have to do to start is just take the square root of both sides, because we know that the square root and the square cancel each other out. So we have x plus 4. And then take the square root of 25. That's just plus or minus 5. And then we get x equals negative 4 plus or minus 5. So x equals 1, or x equals negative 9. It's beautiful. Really quite simple. The thing here is we can make this equation look just like this equation. I've set it up just so that this is actually just a different form of this equation. So it's going to have the exact same solutions. So in order to take this and make it look like this, first let's take a look at x squared plus 8x. Actually, before that, just look at x squared plus 8x minus 6 real quick. Forget that it's not equal to 0. Think, can you factor this? Can you factor it at all? And you maybe look at it for a few seconds and realize, no, the factors of negative 6 will never add up to positive 8. So, no, that's not going to work out. But could, instead of negative 6, could we put a number here that does make it factorable? And of course the answer is yes. There's lots of possible numbers we could put there that would make it factorable. One would be 7. We could put a 7 there. Okay, sorry, this thing is wigging out on me. Hold on. Okay, there we go. So we put a 7 there. That would be x plus 7 times x plus 1. Hold on. There we go. And that is the factored form of this. Okay, 7 is not the only possibility. We could do 12. That would be x plus 2 times x plus 6. That would definitely work. That's factored. Okay, here's the thing, though. Of all the possibilities, and there's lots more, let's choose this one. Let's put 16 there, and I'll show you why. Because when we factor it, we get x plus 4 times x plus 4, and that is x plus 4 squared. Okay. Now, if we had this on one side of an equation and numbers, it doesn't even matter what other numbers are on the other side, we could just take the square root of both sides and would be on our way. Okay. So is that possible? Could we get this on one side by itself? Or this on one side by itself, which comes back to this on one side by itself. Could we do that? Well, we could put ourselves in a position where we had x squared plus 8x by itself on one side. We could just add 6 to both sides. Okay, so if we added 6 to both sides, that would give us a 9 over here, right? So that'd be 9 on this side. But the thing is, that put us in a position where we didn't have the 16 over there. We just had x squared plus 8x equals 9. We could definitely take this equation and turn it into x squared plus 8x equals 9. But to work this out perfectly, we added 16 to this side, so we need to add 16 to both sides. So 9 plus 16 is 25. And look at that, we have this equation is the same as this equation. We could work it out and get 1 and negative 9. Okay. Now, you may be saying to yourself, well, given the choice between solving this one and that one, if we're going to turn this one into that, it probably would have taken less work to just do factoring, and you're probably right. But the thing about this is it works even when the thing that you're trying to solve, the quadratic you're trying to solve, is not factorable. And then that is going to lead us to a position where we can solve any quadratic, whether the answers are imaginary or the quadratic isn't factorable, and that's going to create the quadratic formula. So that's something to look forward to in the next section. I think the next section, yes. Not yet, but it is going to make the quadratic formula. And that's why this section is called this process is why it's called completing the square. Because what we did was take this part, right? We isolated it, and we found this 16, this perfect number that when we tacked it on there, it factored beautifully, factored perfectly into a perfect square. So we completed, found the missing number, the square, so that when it factored, it became a perfect square. All right. But how did I find that 16, and how can we make this a streamlined process so that we can just look at what we have and find the perfect number right away without much work at all? Okay, let me show you both how and why. All right. So what we're looking at is a situation where we would have something like this, x squared plus 8x, and we're looking to fill this in so that it factors out into a perfect square, right? X plus something squared. That's what we're looking to do. All right. So let's assume that we have filled in that spot and that we have factored it into a perfect square. And so that factored form would look something like this, x plus some number squared. All right. So if we make that assumption that we can factor it into a perfect square, let's work backwards and see how we can get from the multiplied out form of this back up to here. Okay, it'll make more sense in a second. Let's multiply this out. That means x plus c times x plus c. That's going to be x squared plus cx plus another cx plus c squared. You got x squared. Let's do it again. X squared plus 2cx. Right, we got two of these, and we got a c squared. Right. This is like a quadratic we would be given, except for the quadratic we're given just doesn't have that last term. That last term is going to be some number squared. It needs to be a perfect square. And that should make sense because we're going to multiply this together. That constant term is going to have to be a perfect square, this number times itself. So how do we find that number to square it? How do we find c to square it? Well, c is also a part of this coefficient. C here is just multiplied by 2, and that gives us the number that we see here. So if we just take that 2c and we divide it by 2, that's going to give us c. We could take that c and multiply it by itself, and that'll give us the c squared that we need for here. Okay, if we apply it to this problem, we'll just take 8 and divide it by 2. That gives us 4. Then we can take the 4 and square it, and that'll give us the 16 that I found before. Okay, let's try it again for a different problem, like x squared plus 4x. What do we need to put here in order to make this into a perfect square so that it'll factor into a perfect square? We'll just take 4, we'll divide it by 2, that'll be 2, we'll take 2 and we'll square it, and that is going to give us the 4 that we would need. Let's try x squared plus 12x. What do we need to put here so that it'll factor into a perfect square? We'll just take the 12, we'll divide it by 2, that'll give us 6. We take the 6 and we square it, that'll give us the 36 that we need. How would this factor? You could try, it wouldn't take long. X plus 6 squared. This one would factor as x plus 2 squared. This one, of course, we already did. It turned out to be x plus 4 squared. So every time we're just filling in this last number, this c, when we talk about a squared plus b squared plus c, we're looking for c so that it factors perfectly into a perfect square so that we can take the square root of both sides and solve it that way. All right. So we'll look at more examples, actually, solve some equations in the next video. Thanks for watching. Hope that was helpful.